Well, good morning, everyone. Whether it's your first time or returning attendee, thank you so much for spending time with us this morning. I'm really excited. Today's webinar is a continuation of last month's. For those that attended, last month we talked about orchestration and automation. So today we'll be talking about CI/CD and in ways we can help your infrastructure, help you secure that infrastructure in your organization. Before we get started, if you do have questions along the way, go ahead and put those in the question or chat box. If we don't get to them, they are recorded and we'll make sure to reach out to you after the event. So John, if you don't mind, we'll get started. If you could advance the slides. So today, let's accomplish a few things as always. Hopefully provide some insight, information that's new to you folks. We want to make sure, as always, it's relevant. Our goal is to make sure we can provide this information that's going to help you in your day-to-day and long-term planning. And then lastly, hopefully you'll see our ability to partner with you, whether that's sort of augmentation or project or just long-term needs. All set, John. So in a moment, I'll introduce you to John, myself as well. We're going to go through CI/CD. John's going to have a lot of the fundamentals, use cases, and we'll have Q&A if available at the end. So what is our team seeing out in the field today? John, members of the SSG team are chatting with clients, and relative to CI/CD, a lot of organizations struggle with keeping configurations current and secure. I think anyone out there that recently has tried to hire security talent knows that it's difficult, knows that turnover and that change can magnify the issues caused by a lack of process. Emerging threats, we talked about last time, just the fatigue associated with trying to maintain a current environment, trying to keep up with alerts. All of that continues to place a strain on the resources. And all of those things can lead to human error when we're trying to support infrastructure and technology. So what about you folks? Prior to the webinar, if you recall, there was some registration questions. I always like to include these as they sort of show where you all are relative to your peers. So do you feel that your current strategy for infrastructure is as timely as possible? About 3/4 saying no, not today. Do you feel that the current strategy is secure? 33% saying no, so most of you saying, yeah, I think we're pretty good, so good news. And not surprising, have you experienced human error while provisioning new infrastructure or deploying changes? So almost 9 out of 10, and that is why we're having this event today. And these next 3 questions, probably again, not surprising. Does your organization utilize CI/CD today? Do we have a directive to deploy this? And do you feel as though you're fully informed on CI/CD? And John, you can see there, all those answers were 100% no on those. And I think that's probably more to do as to why we're here today, because a lot of us don't know how CI/CD can impact us in our organization. So I think that's great. I think you'll find the content very relevant. So as always, our mantra is flexible, resilient, and productive. We want to make sure we can help you in those areas. And John, if you move ahead, we'll do a brief synopsis of the organization for those that haven't been on these events before. 60 offices worldwide. I'd like to say we have a local touch with global reach. Over 3,000 employees. And to the right, you can see the offerings we have, the different practice areas. John, if you just scroll ahead, we'll see those visually. So today, Bottom right, we're talking about security. But please just know in all of these different technology sets, we are a professional services and managed services organization. So whether it's collaboration, which is a big part of organization today, data networking, Microsoft, our Cloud Blue cloud services, in any of those areas, again, we are pro services, managed services. We want to support you from the initial design through implementation and post support. So John, if you move ahead, we'll talk a little bit about the security practice. So we have three parts of the security team. Number one is our advisory services. And you can see here, I would say honestly, three to the right now seem to be conversations we're having almost on a daily basis. So penetration testing, vulnerability assessments, and for some organizations, the vCISO, so virtual Chief Information Security Officer services. And I think all of these really come into play relative to just the continued demand and change that the pandemic had. So making sure we're safe, we know our systems are in place, what are the vulnerabilities we have, and then helping us move forward. Next slide, John. One of the other practice areas is our managed service security infrastructure. So if we're experiencing staff turnover I mentioned before, if we're looking to remove some of the burden from our team, we have an entire operations center that can manage your organization on your behalf or help your team. We have a dedicated portal that your support staff can log into. And again, we can help you sort of reduce that ownership of and costs associated with managing this infrastructure yourself. I would say in this suite of services right now, we're seeing a lot of support around MFA and EDR. And conversations in the last few months have really been around requirements of cybersecurity insurance. So if you have initiatives to try to reduce that cost or make sure you're up to their standards, these services can certainly help. And I would say, John, if you just scroll ahead for a second. The three key areas here is we are absolutely dynamic and scalable to help you manage those devices. We're agnostic, so we don't really care what systems you have in place. The Operations Center is very flexible. We'll have SLA guarantees or as performed needed, whatever meets your requirements. And as I mentioned a moment ago, we are local touch, but global, so we can support your infrastructure no matter how big or small. Next slide, John. And the third practice area is managed detection and response. We have an MDR offering that allows us to continuously monitor your environment, try to help you minimize the threat landscape. And as I mentioned before, some of the remote workforce definitely is a big catalyst for this. Folks that are moving to cloud or hybrid cloud. In some customers today that have IoT, a big part of this offering. And lastly, John, if you just move to that next slide. Again, we'll see where we're talking about a holistic approach with our MDR offering, the ability for us to manage and detect in your environment. Again, very flexible. The way we do business with our customers in this program is very transparent, very easy, very predictable. And once again, we have the global reach, so we are very specific to data residency and can make sure we're addressing those needs. So with that, I'm Joe Paquette, Director of Business Development in the Northeast. In advance, John, I want to thank you very much. I've seen this great content. And so with that, John, I'll turn it over to you and look forward to today's content.
Thank you, Joe. Good morning, everyone. My name is John Bissonette. I am one of the security solutions engineers here at New Era Technology. And my role encompasses DevOps, DevSecOps engineering, and cloud security architecture. So let's jump into it. First things first, I just want to set some terms and definitions so that we can establish some common ground. Starting with DevOps. This is a term that I think a lot of people have heard and may not be completely understood, but it really is best defined as like an umbrella term for a culture change within IT that focuses on rapid IT service delivery and improved collaboration. The thing with DevOps is it's not a framework, it's not necessarily a defined methodology or standard, but it's a collection of things. And especially automation tools that can leverage increasingly programmable and dynamic infrastructure. CI/CD stands for continuous integration and continuous delivery or continuous deployment. And this is the concrete example of DevOps. These are the ongoing and continuous automated processes for deployment, integration, building, monitoring throughout the entire software development lifecycle. Here, we're going to talk about templates a lot, and template is simply a document. It's got a schema, a set schema that describes a set of infrastructure resources. These templates are traditionally authored in either a serialization language or general purpose language. So serialization languages are programming languages that are really designed to transmit or translate data structures between systems and our end users. Examples that you may have heard of are JSON or YAML. A general purpose programming language is a programming language designed to be used for building software across the entire spectrum of application domains for anything. And so things like TypeScript, JavaScript, Python, Java, those are general purpose programming languages. The domain-specific languages are programming languages that are designed to be used for a very specific area or set of systems or services. And gates are going to be places within a pipeline that we're able to set a pause on the execution that allows us to set a condition that needs to be met, whether this would be approval, scanning, testing, the like. So let's look at some of the problems that are faced without having CI/CD. And it really comes down to manual changes being made to an environment or non-automated. These problems, first and foremost, could be start with the introduction of human error. And it's inevitable that human error will be introduced, especially when you talk about performing tasks many times that need to be performed many times in many places. And these can introduce security risks of all types, misconfigurations, relaxed permission sets, anything that's designed to cut a corner, perhaps in the development of infrastructure, can lead to the introduction of changes that were unintended. The manual changes can cost a lot of man hours, and that also can directly lead to security risks. Having a developer who's been working for 16 hours straight trying to deploy a bunch of services across a bunch of different accounts, once again, can maximize the probability of human error being introduced, as well as take away work cycles for responding to incidents or for hardening infrastructure for other features. The infrastructure changes can be very difficult to produce at scale, if not impossible, and sometimes in a disaster response scenario, disaster recovery. So a change that might seem simple, being made to a single account can be done by one person just fine. But if that particular change needs to apply to 4,000 accounts, then it becomes quite a different story. And when it comes to disaster recovery, there are times where perhaps the security folks that are in charge of managing a disaster recovery response aren't able to have complete understanding of how the systems were stood up, how they're currently functioning, how the configuration changes that were made to bring it into its current state occurred, especially if the teams are siloed. And last but not least, all of these manual changes, because it could be possible to have every single developer having access to an environment, they're all able to make changes from their own machines, then you start becoming difficult to track down when and where and who made specific changes and what they did to affect those changes as well. Well, let's look at some sort of real world examples of these security risks at work. JP Morgan Chase had suffered a breach that exposed 76 million households and 7 million businesses, all because a single web server didn't have multi-factor authentication enabled. CI/CD absolutely would have helped prevent this because the automation will not overlook the patching of a server. The targets for automation are specifically set, and it will ensure that these systems have their package deployed. And if there was one person who was given a list of servers to update, it's quite a bit possible they could have overlooked one. Reindeer, it's a defunct marketing firm, had open S3 buckets on AWS that exposed the data of 306,000 customers. Likewise, Alteryx accidentally exposed marketing data on approximately 123 million American households because of misconfigured S3 buckets. S3 bucket misconfigurations are rampant and a very big issue in the security space right now. So CI/CD would have caught these misconfigurations quite early on, both with manual code reviews that are enforced, as well as with IAC infrastructure as code scanning technologies that would have scanned the templates that deployed that infrastructure and alerted that they had insufficient security controls. Capital One had suffered a breach that leaked more than 100 million consumer applications, primarily due to misconfigured web application firewall. And what's really interesting about this case is that it wasn't the web application firewall itself that was the cause of the breach, but the infrastructure that the WAF rides on, the server that it was deployed onto, had as part of its instance profile an overly permissive set of permissions that allowed an Amazon employee to take advantage of that and to extract that data. So all of these risks could have been mitigated by having automated processes in place by the CI/CD system and never would have reached a testing environment or much less production. So looking at CI/CD and DevOps and the relation between the two, they are very closely related. DevOps can be considered like a change in culture that focuses on rapid IT service delivery, as previously mentioned. It basically turns the entire software development lifecycle into a continuous process, like a wheel. And we see that the plan, code, build, and test phases of dev are summed up nicely in continuous integration. It fits very nicely into that, as well as release, deploy, operate, and monitor being the continuous delivery and continuous deployment portion of the operations. Some of you may have heard of DevSecOps. That is simply DevOps with security baked in at every stage. So putting security as a primary focus in every part of the software development lifecycle. It's not a single task or a single group of tasks that can just be checked off, but every single part of this cycle should have security as a forefront consideration. And that's DevSecOps as a philosophy. So we'll start getting into some of the fundamentals of what makes up CI/CD. And we start with infrastructure as code. Templates can be written, as I had previously mentioned, in serialization or domain-specific language-based tools. Some of the most popular tools out there for this are Puppet, Terraform, Ansible, and Chef. And some other tools that use general purpose programming languages, such as the AWS Cloud Development Kit or Pulumi. They let you author your infrastructure using TypeScript, JavaScript, or Python. And each of the major cloud service providers has their own infrastructure as code service. For Amazon, that's AWS Cloud Formation, which uses YAML or JSON for their templates. Azure Resource Manager for Microsoft Azure, that also uses a JSON-based template. And Google Cloud Deployment Manager, which I guess could be considered a bit of a hybrid, as you can write your infrastructure in Google Cloud with Jinja templates, which is a serialization-based language, or with Python. So for a quick example of a template, we have on the left here, this is a CloudFormation YAML template that describes a VPC, a virtual private cloud, in Amazon. We can see that this template has a properties block with CIDR IP address block, enabling DNS host names, host support, instance tenancy. With the AWS Cloud Development Kit written in Python here, this is the exact same infrastructure. So it looks very similar, but this is a Python class that can be executed within the context of a Python runtime. And we'll deploy the exact same infrastructure as the template here. So the other fundamental part of the CI/CD is the pipeline, right? And so here we can see a great example of abstract view of what a pipeline looks like. And so the cool thing that is to be noted about the pipeline is it's a series of tasks that are run sequentially. It's extremely configurable. There are many types of tasks that can be performed by the various pipeline agents. There are also integrations that the pipeline service providers offer with other tools that within the software development ecosystem. And what's cool is the pipeline itself can be versioned in version control, as there are templates that describe how the pipeline works. So here we can see the code, the commit, and the related code. These would make up an artifact. Artifacts are tracked by the pipeline, so any changes that are made will trigger a release or a run of the following pipeline. So these artifacts will generally take the form of some sort of version control system like Git. Subversion is another, or Mercurial, but Git is by far the most popular. And so if someone checks in some code and commits it to the repository, that will kick off a release. And this release starts with the continuous integration pipeline, and you can see there's a build test, unit test, integration test, and this is just an example and somewhat related to application development. These tasks can be any sort. It can be a command line interface call, an API call made to a third party. It can be to run a program, any sort. So it doesn't necessarily have to be these things in this order. And we get to the continuous deployment stage of the pipeline, which will actually deploy the resources into the various environments that it's directed to. This is more concrete.
Hey, John, can you hear me?
Yes.
We're losing your audio every once in a while, so I'm not sure if if you're moving on your end, but we're losing your audio.
Oh, not bad. Okay.
You're good right now, but maybe if you just make sure
Yep.
There's no changes. Thanks.
Sorry about that. So this is an example of a CI/CD pipeline with Microsoft Azure DevOps. You can see right here, this would be the trigger details. We can see that this particular run was manually triggered by myself. We have our artifact details. So this is a Git repository called AWS Customer. We can see right here, this is the commit hash the actual commit that triggered this particular deployment, and we see that it's tracked off of the master branch. Here are the pipeline stages. Each of the stages can have one or more jobs, and we see right here, this is an example that we'll get into a little bit later. This is an approval gate, and so that the pipeline ran until it was completed. So there's plenty of things to think about when trying to choose the right CI/CD service, and as always, you must choose the right tool for the job. So starting with what are my licensing requirements? Do I need software as a service or an on-premise platform? Is community plugin support important to me? And one of the most important considerations is a built-in secrets vault. So the CI/CD platform will be deploying critical infrastructure, and that infrastructure could have things like databases, domain controllers, Active Directory forests, the nature. So there will be passwords and credentials of various types, API credentials, service principals. These things are going to be very tightly controlled. So that secrets vault should have enterprise-grade encryption, role-based access controls, auditability for things like add, modify, remove, and view events on the secret value. And that's very important to consider. Another thing are the built-in integrations that the provider provides. Does it integrate well with other version control systems, with major cloud service providers and infrastructure as a service, platform as a service providers, whatever your business needs? You look at agentless versus agent support. Do I need to install an agent in my own environment, or will this service allow me to run without having to install any infrastructure in my own environment at all? And last, very important, is what are my team's capabilities? Do I have people that are very well versed in Python already? Is that the type of shop that I run? Perhaps I might want to look at the CDK. If I don't have any engineers that know, that are working in general purpose programming languages, perhaps something like CloudFormation, Circle CI would be better. You know, those are key to reducing the technical debt that you might incur. So I'd like to get into some of these example use cases for you and be able to demonstrate how various pipeline security mechanisms can prevent some of this misconfigured infrastructure from being deployed. And these use cases we'll jump into are going to be around managing security groups, managing roles, network infrastructure, and showing some of those approval gates. And some quick notes about these demonstrations. So they were created in Azure DevOps. The templates themselves are AWS CloudFormation YAML templates, so they are that serialization language. The deployment targets AWS US East 1 region in Northern Virginia. And the pipeline gates that we've put in place are an infrastructure as code scanning gate and an approval gate. So first one here, we have managing security groups. Right here on the left, I have a template it's an abridged template, but one of the resources that it defines is a AWS EC2 security group. So conceptually, security group can kind of be considered something like a firewall rule, but they are different. The security group is going to define access rules to a set of target resources that the security group is a boundary for. Now, there's two very important properties here to pay attention to, and that's the security group egress, or the outbound rules, and the security group ingress. Now, the egress allows HTTP, which is TCP port 80, across any address in AWS CloudFormation 0.0.0.0/0 as a CIDR IP block. It represents all IP addresses or all traffic. So all traffic is allowed in outbound on port 80 and to support HTTPS, outbound on port 443. the misconfiguration that in question that we wanted to have caught by the IAC scans is right here. So this could be an example of a possible copy paste or just a overlooking of the rule itself. Now, this is a valid rule, but what we're doing is we're allowing all traffic inbound to the server over port 22, which is SSH secure shell. This would be, and of course, this triggered a high risk security alert by the IAC scanning tool when it parsed this template. So the IAC scan, when the pipeline runs triggered, the IAC scan commences. We don't want anything that this IAC scan alerts on to make it into our environment. So the pipeline will stop before it deployed anything after catching this alert. When looking at managing roles in a similar fashion, the infrastructure as code scans caught a misconfiguration in the policies of the IAM role. IAM is AWS's Identity and Access Management Service. So in the policies block here, we see a policy statement that allows all actions on all resources. So that effectively and full administrative access to the AWS environment, which probably isn't what we want, only in very, very, very specific cases. So IAC caught this and generated an alert for AWS IAM policies that allow full star administrative privileges. And once again, this template would never make it into production, much less into like a test or QA environment as well, once these scans alerted. This is when looking at this managing network infrastructure template, this is a great example of something that the IAC scan didn't catch, but a manual review would, and is a great example of the belt and suspenders approach to security that CI/CD provides. In order to further explain, so we have in the security group ingress rule a valid IP address for port 22 and SSH. Let's just say that the developer wanted to have easy SSH access from his home workstation to this particular server. Now, because it's a valid IP address, the IAC tool would not alert on this unless, of course, there was custom logic written for that scanner. We're not going to get into that. Let's just say that this IP address was not part of the corporate network. And so during a code review of the changes that are being introduced, we can see that the deployment is rejected because this IP address is not part of the corporate network. Therefore, the endpoint can't be tracked. We can't have some sort of endpoint security installed. So we don't want to allow that at all. And here we can talk about the approval gates, and this specifically is an approval gate as Microsoft's Azure DevOps allows. So we see in this block here the list of approvers, anybody in the org that can be added as an approver. The approval order is pretty cool. So we can allow for anybody in any order as long as everyone approves. That's what this any order is for. In sequence, so in this case, in order for a pipeline run to proceed, Kevin would have to approve first, Jacob second, or any one user from the above. The timeout allows for time for people to actually look into whatever is being changed and approved. And so the cool thing about an approval gate is it doesn't have to be a single person or a single user. You know, this could be a gate for the network team to be able to check out the change and make sure that everything's copacetic on their end. It could be an approval gate for security or operations, you know, to all have visibility into the change and understand what's being done and then be able to sign off on it. and some approval policies will be presented as well. So the user requesting the release or deployment should not approve it. That might be something that an organization wants to enforce, as well as skipping approval if the same approver approved the previous stage. And here is an approval gate in action, another screenshot. We can see that this particular stage, it passed because it was approved by Kevin. And the rest of the people here, it skipped their approval as we only needed the one. So CI/CD and the automated processes that it entails can save a tremendous amount of time when working on any kind of non-trivial infrastructure or non-trivial configuration change over any kind of traditional manual deployment change management scenarios. But it's best demonstrated during operations that must occur at scale. As I had previously brought up an example, of a change that might take 2 or 3 minutes in the console or running a quick CLI command from your terminal, that would be, I guess that'd be fine for one account perhaps. But if that change needed to replicate across dozens, hundreds of accounts, that's when the work scale becomes impractical, and in some cases it could be next to impossible. So the CI/CD can ensure that these changes are going to be deployed to the environment, and it will execute them in parallel or sequentially. Either way, it'll save a massive amount of time. And there won't be any work loss due to troubleshooting the misconfiguration because of a human error. So another thing to consider is you're only as strong as your weakest link, and if the pipeline itself is not secure, we can't guarantee the security of the infrastructure that it is deploying. So some of these important pipeline security considerations, I've said a lot about infrastructure as code scanning. They're also called static code analysis. Integration of these tools would be very important to be able to catch code smells, misconfigurations, any errors that would preemptively catch an error. Very important to have those tools in place. Progress gates, whether they're an approval gate, a gate that depends upon the passing of test suites or scans, things of that nature. Identity lifecycling, any identity, whether that's a user account or a set of API keys for any service or user, service, or system that interacts with the pipeline, needs to have credential lifecycling in place. An example would be if I left the company, we would want to have a system in place that will automatically deprovision my credentials and ensure that I lose my access to the pipeline. Or if a service is being deprovisioned, its API keys need to be life-cycled. That way, an attacker couldn't assume those keys and then have unfettered access to the pipeline. Code reviews are really important. It's great to have a second set of eyes on any change that's being introduced. And code reviews can occur at multiple locations. And that's what those approval gates are also for. Trusted networks, those would be the networks that the CI/CD pipeline deploys into, as well as its own. And so something like whitelisting the identity of the CI/CD service so that only IP addresses that are assigned to that service can interact with the environment, with the infrastructure that's being deployed. Therefore, we would not have to worry about perhaps the CI/CD services principal credentials being used to deploy infrastructure from a different location. We would ensure that only the CI/CD service can deploy. monitoring of the CI/CD service is incredibly important so that we can audit all these events and this guarantee our compliance. And also third-party integrations or extensions to the pipeline. So this is those tools that we can that a company or other users in the community can write tasks that will, perhaps integrate with Jira or integrate with PagerDuty or any one of a number of Salesforce, any one of a number of outside services. So those integrations have to be audited. They could be a vector for supply chain attacks, similar to what we have seen with SolarWinds, where SolarWinds had code that was signed by itself, but it was maliciously inserted into the code base. There's other examples of this occurring and is key for the pipeline itself to ensure that the code that you're running and executing in the pipeline is safe. And some of the ways that CI/CD strengthens security for us at New Era, we have ease of deployment and deprovisioning of resources. This is a guaranteed configurations. Whether those configurations are within an application, a server, or a service, they are guaranteed and audited. So our solutions are guaranteed stable from a security standpoint, meaning we have deployed, tested, performed QA. We have had some analysis into how they function within our non-production environments, so that by the time they get promoted to production, we know that what these solutions are going to do. They're going to, if there's any errors that are going to pop up, if there's any misconfigurations that we have to fix, all that has been done and performed. That work is in place. And so once we promote it to production, we don't have to worry about whether or not we've built the architecture correctly. We have an enhanced ability to rapidly iterate upon infrastructure. This really can't be understated enough. When it comes to the rapid iteration, we not only are able to take a change, like for example, a few months ago, Log4Shell was a critical vulnerability that was discovered in the wild that took advantage of a Java logging library called Log4j, and it allowed for remote code execution. So a patch was pushed out for any service that uses Java, and we were able to push this patch out within hours because of our ability to rapidly deploy any change. We commit the code to the repository, kick off a run, watch it go through, test it, make sure that everything got updated correctly, and we can promote to prod. So this isn't just for rapid iteration, not necessarily being limited to feature development, but in response to security incidents or bug reports or things of that nature. All changes are reviewed multiple times. There's architecture review, there's a code review during a merge to non-production, and there's code reviews that are put in place before a promotion to production. We're able to enforce standards. So things like logging standards, different controls, documentation. Another thing that can't be understated enough is the central repository of all resources. Everything that's deployed is checked into version control, including the pipeline. And so any changes that are made in our environment are audited. We know exactly when those changes were introduced, what they were, who approved them, and when they were deployed. We have built-in secrets management. So of course, API credentials and master user passwords, for example, things of that nature are all handled by our CI/CD service. They are securely passed to the different cloud service providers that in the areas that need them. and they are encrypted with very strong audited encryption technologies. And we're able to enforce assessments, things like the infrastructure as code scans against compliance frameworks. We have IAC scans against organizational standards. Those are standards that we have set for ourselves. Static analysis of the templates and of any application code that gets committed. So it really is a force multiplier for us.
Yeah, John, I wanted to just highlight, and you're doing so here, but just again, how much for New Era security automation and CI/CD play in our offerings, particularly the MDR offering. It's just been such a critical part of the development and deployment of that offering to our clients.
Oh yeah,
Yep.
and heavy automation of security services is something that allows us to provide guarantees to our clients. And it's not just the automations of the responses to incidents and things of that nature, but the actual provisioning of our infrastructure, the infrastructure that all our services ride upon, is also highly automated. And so we essentially are able to front load the technical debt through our architecture, design, and reviews, and really nail down a hardened solution. Once we've got that in place, we can deploy it and rapidly iterate upon it, and ensure that those services are always kept in line with standards, compliance, and the current threat landscape.
Thanks. Yep.
Yeah. And that sums it up. So thank you very much, everyone, for listening.
Hey, John, before I didn't want to break the presentation before, but I did have a question. If you could, if you don't mind, respond to this. Yeah, and I'll just read it here. What if I have something I need to be different between the specific accounts regarding the same infrastructure?
Oh, yes, wonderful. So the templates have a parameterization option. So that's not just the serialization or DSL based, but the general purpose programming language based templates, where you parameterize the template to make it essentially a generic piece of infrastructure. And each one of the target locations that you want that infrastructure deployed into can provide its own set of parameters that are different, specific to it. So using the parameterized templates and the individual parameter files, that's how we can ensure that a given piece of infrastructure is configured specifically for the account that it needs, or the target location that requires it. And that's a very powerful way of modularizing and making infrastructure reusable in a way.
Awesome. Thanks, John.
Thank you.
Yeah, so John, if you don't mind moving ahead, the what's next is simple. If you want to engage with the team, one easy way to do it on the post-event survey, which will be coming to you. There's just an opportunity to talk, to check off the whiteboard session, and all that really is an opportunity to chat with John and his team about the topics we presented today. And really what we're trying to accomplish is, how could this be relevant to your organization? Just a Q&A session, ability to talk about these concepts at a high level, perhaps dig deeper if it made sense. So again, in that survey, just check that off. And we'd appreciate your feedback and on any of those questions. It really helps what we're trying to do here. So with that, John, I think we're at the end. I want to thank you so much for your time and effort today. If you do have further questions, you can note them on the survey. You can reach out to your account manager. John, one more slide. There'll be an email here as well. If you don't know who that is, just email solutions@neweratech.com, and we'll make sure that we get a reply to you. So once again, everyone, thank you so much for attending, and we look forward to seeing you on the next webinar. Take care.